Hi, everyone. Just to introduce myself again, I am Ghada Al-Mashagaba from the University of Connecticut. Today, I'm going to tell you about a state growth control solution for automated market makers. And the goal is to show or to explore the utility of a new sidechain architecture in optimizing the storage overhead or cost of AMMs. This is a joint work with my students, Nick and Muhammad from UConn. So the fact that we are here in the TLDR conference means that we all recognize and appreciate the benefits of smart contract-enabled blockchains in allowing us to build fully decentralized systems and services. They support attractive features. They allow users to deploy arbitrary programs that can be executed in a transparent and publicly verifiable way. And they allow us to build a variety of applications, such as crowdsourcing, decentralized finance, and distributed resource markets. The focus of this work is on a popular application under the DeFi category, which is AMMs. And allow me to provide a brief background just to remind you of the types of transactions that are exchanged in AMMs. So AMMs build a platform for automated token trading where they establish liquidity pools such that a liquidity pool is used to trade two tokens or pair of tokens against each other. Clients will submit their trading orders in the form of swaps or swap transactions, and they pay fees for the owners of the liquidity that was used to fill in their orders. At the same time, we have the liquidity providers who supplement these liquidity pools with tokens, and they do that using mint transactions. And they do that, of course, to collect fees that they can get using collect transactions. And these liquidity providers can manage their liquidity positions or even withdraw them using burn transactions. AMMs are a huge industry. There are several examples of successful deployments out there. And they led the research community to explore interesting topics to improve the initial designs that we know. Unfortunately, at the same time, AMMs are a huge scalability problem. Their popularity and high trading activity resulted in millions of on-chain transactions, and this translates to large storage overhead and high transaction fees. And at this point, we asked this question, hey, can we control the on-chain or the ever-growing on-chain state of AMMs while preserving their correct operation and at the same time preserve the desired features that we require from a DeFi protocol? And I'm pretty sure that you guys now will say, okay, this is all the news. So blockchain scalability is a well-known problem, and there are several effective solutions deployed and used out there. However, using these solutions in the context of AMMs will introduce performance and security issues and even may not cut the cost of the storage or their storage overhead. In terms of sharding, there is the question of how to shard an AMM. Recall that an automated market maker is a single application by the end of the day. So if you want to put that on a single shard, that shard will be overwhelmed. Or you might say, okay, let's shard the AMM itself across different shards, but this will lead to high volumes of cross-shard transactions that will degrade performance. Rollups, on the other hand, yes, they cut the storage cost because most sharding, or let me just remind you that most sharding solutions, they don't prune the blockchain state. Everything will still logged on the chain. But rollups avoid that. However, they have their own limitations. In terms of zero-knowledge rollups, they require expensive zero-knowledge proofs to be generated, and this cost will increase when you attest to complex or sophisticated transactions. Optimistic rollups, on the other hand, they require long contestation periods on the order of days, and this will degrade performance, not to mention that there is the problem of how to incentivize untrusted verifiers to check or validate the state changes that were produced off-chain. Side chains, unfortunately, most of the existing solutions until now, they focus on two-way peg, which is basically transferring the currency between the main chain and the side chain. And all of them, they view these two chains to be completely independent. Still, we believe that side chains have potential to solve the problem. And indeed, in a recent work, we showed or we built a new sidechain architecture that allowed us to have the two chains depend on each other, share the workload, and even prune the blockchain size. And this led us to exploring the following direction. How about we combine the ammBoost architecture, this is a new sidechain architecture, with AMMs, and this produced a new system that we call ammBoost. And again, it is not about, hey, this is the best solution ever. It is about exploring the direction of sidechains, see whether we can even combine them with other scalability solutions to improve the state and the performance of AMMs. Let me first provide a quick overview of ammBoost, just to know what is this architecture about, and then I will tell you more about ammBoost. So the side chain in ammBoost, as you see, runs in parallel with the main chain. It runs in epochs, and it is composed of two types of blocks. There are temporary meta blocks that record all the traffic, all the transactions that are processed by the side chain. And there are permanent summary blocks that will summarize the state changes induced by the meta blocks. The side chain is managed by a committee from the main chain miners. So for each epoch, a committee will be elected, and this committee will mine a new meta block in every round during that epoch. And in the very last round of the epoch, they will mine a summary block that includes the state changes. So it is just a brief summaries about what happened so far. Also, this committee will issue a sync transaction at the end to sync the state variables on the main chain with these state changes. So we keep the main chain as the single source of truth about the system state. Furthermore, once this sync transaction is confirmed, all the meta blocks that correspond to this sync transaction will be pruned. So this will reduce the size of the side chain and consequently the size of the main chain. Splitting the traffic or the workload between these two chains, just like to give you some background, ammBoost, we introduced that for distributed resource markets. Think of Filecoin, LivePeer, these are some examples of such systems. And what we do is that all the frequent and heavy service-related traffic that can be summarized will be processed on the side chain. However, anything else that must be processed on the main chain, beside, of course, the state variables of the system, will stay on the main chain. So we are taking this framework, and we wanna, which is, because they share, or the two chains, they share the workload, they have a dependency between each other, and we take this framework and we wanna apply it to AMMs. However, it wasn't as easy as it sounds. So at the beginning, I was like, okay, this is a quick paper, we will do that very quickly. It is just another use case of ammBoost, but it wasn't the case because the setting of AMM is very different from the original setting of distributed market makers that we targeted at the beginning. First of all, remember the AMM is an application deployed at the application layer of the blockchain. This AMM doesn't have any say or control over the miners or the network protocol that is run by these miners. Furthermore, there are no actual tokens on the side chain. The tokens are still managed on the main chain. However, we have to find a way to allow processing the transactions on the side chain without having actual tokens. The last issue is because now we have a side chain that is separate from the main chain, and even the main chain miners may not know about the side chain, we need a way to authenticate that, hey, the syncing process was issued by the rightful committee. So we need some authentication mechanism to allow saying that, okay, these are the correct state changes or were produced by the rightful people before accepting these changes. Addressing all these challenges led to the design of ammBoost. As you see, the figure is very similar. The differences are as follows. First of all, the side chain now will have its own miner population. So you can think about it that the AMM now has its separate set of miners. From these miners, each epoch, we will elect a committee. This committee, just like before, will mine summary blocks and meta blocks. The AMM itself now is divided into two parts. We have the main chain part, which is a smart contract or a set of smart contracts. This is up to the developers, which we call a token bank. This token bank manages the actual tokens on the main chain, manages also the payouts and the deposits of the users, manages the liquidity pools and the liquidity positions. The second part of the AMM is the implementation of the sidechain in the sense that all the frequent transactions, which can be easily summarized, including swaps, mints, burns, and collects, will be processed on the sidechain. The main chain, whatever I mentioned about token bank, and any additional service that must exist on the main chain because it requires actual tokens on the spot. The popular example is flash loans. Flash loans, we cannot process them on the side chain. They have to stay on the main chain. As before, meta blocks will be produced, will be summarized, and then the committee will invoke a function called sync in token bank to sync that smart contract with the liquidity positions or the updated, let me jump here, the updated liquidity positions of the users, the updated pool balances, and the payouts and the pay-ins for the users. So in a nutshell, ammBoost includes new techniques compared to the original design of ChainBoost. You saw that the sidechain now has its miner population. We also introduced other techniques to allow processing the sidechain traffic or the transactions on the sidechain based off the correct state of the liquidity positions and pools without having actual tokens. More details I will provide using this figure. So yeah, token bank is the part of the AMM on the main chain. Everything else, which is transaction processing, is on the side chain. As a user, I have to start with providing a deposit of all the funds that I expect to use during an epoch to token bank. So I will put that money there. And after that, once the epoch starts, the sidechain committee will retrieve the latest state from token bank, including the current liquidity positions, the liquidity pool balances, and the user deposits, which what we call here main chain deposit. Then if I want to issue a swap, say that I want to buy 20 token Bs using 50 token As, and my initial deposit is 100 token A, the sidechain will see that, okay, I have funds or deposits to cover this transaction. They will accept it. Then the transaction, which is a swap, will be processed using the exact logic or the same logic of the AMM based off the liquidity or the balances that were retrieved. This means that 50 token A will be deducted from my deposit, and I will get new token Bs, say that they are 20. This logic applies to all other transactions. Everything must be supported by the epoch deposit. So as a user, you have kind of like to I don't know, give yourself some slack in the sense that provide more deposits just in case you might need more during the epoch. Then at the end, all these transactions that were processed will be summarized. And at that point, we have what we call user or per user payouts and pay-ins, which are the processes related to your deposit, meaning that how much you owe that will be deducted from your deposit and how much you will get from the new tokens that you got. Okay, and for syncing, for authentication of the syncing process, which includes all these summaries, we introduce a threshold signature-based quorum certificate. I'm not going to talk about it now. You will find the full details in the paper. But rest assured, no one can just like call sync just because it is a public smart contract. You must be part of the legitimate committee of that particular epoch. We analyzed the security of the system, and we have built a proof of concept implementation of a Uniswap-inspired use case. My students are still working on the experiments. We expect to have them ready next week for the AFT deadline. For this reason, I'm not gonna talk more about the results. However, the preliminary results that we have shows around 90% reduction of the on-chain state or storage cost of the AMM, and ammBoost allows the AMM to scale to significantly large workloads. All of that will be confirmed once we release the paper. To conclude, this work introduced a secure sidechain-based framework to control state growth and boost throughput of AMMs. We provide formal treatment of the system design as well as performance evaluation. Among the future work directions, these we expect to be more in the economic side, which is the general theme of this conference. We will look into transaction fees under this hybrid architecture and perhaps the use of the Chain Boost framework to support privacy-preserving AMMs. Thank you so much, and happy to take questions.
Does it break composability with other DeFi apps?
No. So I have to say that I'm not 100% sure about the answer, but our goal of keeping the state of the AMM on the main chain, say that Ethereum, is to support that composability. Because we were asked this question several times. Why don't you move the whole thing to the side chain and then just use a bridge to transfer tokens back and forth? But yeah, exactly. This will make the AMM isolated, and composability will be very hard.
What is the unhappy path in case of a safety or liveness failure by the sync committee?
Okay, that's a great question. We show that this will not happen just because we introduce additional techniques to recover from these interruptions. So first of all, the committee, we assume that it has an honest majority based on the consensus protocol that they run. So by the security of the consensus, we're good. However, it could be the case that maybe some sync calls were dropped down, so you didn't sync token bank. So we have a technique that we call mass syncing. So any new committee will look back. If any syncing function call is missing, they will submit kind of the whole summaries, even for the previous epoch. And yeah, there are also additional techniques. But yes, we analyze the security of the system, which is basically to guarantee that safety and liveness are not broken.
Thanks.
We have time for one more. All right, let's thank our speaker one more time.
Thank you.